Good day! This is Group 4 from BSMU 3B and we will be presenting the Project 2 video presentation for the subject Material Science and Engineering. In this video, you will learn about two equipments. First, the fatigue testing machine and next, the torsion testing machine. So sit back as we unravel and explain to you these two equipments.
First equipment, we have the fatigue testing machine. Fatigue testing machines are used and built to determine and evaluate the durability of a material, component or product, and are suitable for tensile, compression, and alternating load tests. The goal of a fatigue test is usually to estimate the lifespan of a material subjected to cyclic loading. However, fatigue strength and crack resistance are other frequently sought parameters. The total number of cycles that a material can be subjected to under a particular loading scheme is known as its fatigue life. A fatigue test can also be used to determine the maximum load that a sample can tolerate over a certain number of cycles. All of these properties are critical in any industry where a material is subjected to varying rather than constant forces.
Parts or components. The fatigue testing machine essentially consists of the spindle with the specimen receptacle, the drive motor, the load device, the switch cabinet with the electrical control and counter, and the protective hood. The test bar is clamped in the spindle on one side by a cullet chock and guided on the other side in a floating bearing. Loading of the specimen is performed using a spring balance and the floating bearing. Pre-stressing of the spring balance and hence adjustment of the load is performed via a threaded spindle with a hand wheel. The set load can be read from a scale on the spring balance. A digital counter records the number of load cycles. The counter may also be switched to rotational speed measurement. The rotational speed is then displayed in revolutions per minute. The pulses for the counter are supplied by an inductive proximity sensor on the motor coupling. If the specimen ruptures, the motor and the counter are halted automatically via the proximity switch. The motor protection switch, emergency off switch, and counter are housed in the switch cabinet. The spindle is fixed in a ball bearing with housing. The spindle is driven by a smooth running AC motor.
How to use the fatigue testing machine experimental setup. The following steps should be performed before carrying out any experiments. First, fold up the protective hood, then relieve the load device using the hand wheel by moving the floating bearing down to the bottom. Remove any specimens which may be in position. Lightly tighten the union nut on the collet chuck. Next is to fold down the protective hood. The unit can only be placed in operation if the protective hood is correctly closed. Loosen the emergency off switch. Reset the counter using the RST button, and the counter must display 0. Check whether the spindle is running smoothly and true. Check whether the counter is counting correctly, approximately 2.8 load cycles per minute. It is possible to display the revolutionary speed in RPM by switching over with the SEL button. Check whether the automatic stop device is functioning. To do so, raise the floating bearing on the load device by rotating the hand wheel, and the motor should then be stopped by the proximity switch. Lastly, when safe functioning of all components has been established, the experiments can now begin.
How to use the fatigue testing machine in performing the experiment. Once safe functioning of all components has been established, the experiments can begin. The first step in performing the experiment is to insert the test bar. Actuate the emergency off switch by pressing down. Relieve the load device using the hand wheel. the floating bearing must be at the height of the spindle. First, insert the test bar in the floating bearing of the load device. Insert the test bar in the collet chuck and push in as far as the end stop. Carefully tighten the collet chuck using a wrench. Check the concentricity of the specimen by rotating the spindle by hand.
How to use the fatigue testing machine in performing the experiment. To start the experiment, pull down the protective hood. The unit can only be placed in operation if the protective hood is correctly closed. Loosen the emergency off switch. Swiftly apply the required load by rotating the hand wheel. Read off the load from the scale on the spring balance. Reset the counter using the RST button in order to begin counting. The next step would be terminate the experiment. The motor halts automatically when the specimen ruptures. Read off the number of load cycles from the counter and make a note of the number, or manually stop the experiment after the required number of load cycles by switching off the motor. Remove the specimen. Repeat the process with the test bar. Before the safety precaution, here's a video of showing fatigue testing machine.
Welcome to the lab number 4, fatigue test. So regarding the fatigue test, before we go to the detailed experiment procedure, so I would like to share regarding the objective of the fatigue test lab. So here, the main objective is to determine the fatigue limit of the specimen using SN curve. In my hand, we have a 5 fatigue specimen with same material and same dimension. So this is a fatigue test that we will use to proceed the fatigue experiment. So there are two variables involved in this experiment, which is the load apply and the output is number of cycle. So firstly, install the sample at the machine like this. Then place the cover like this. Okay, so you can see here, this is a spring mechanism to give the force to the sample. So according to 5 samples that given to you, you can choose 5 different load value according to your group lah. And then on the machine, apply the force. For example, here I'm applying 100 Newton. 100 Newton can be confirmed by, you see this indicator. Okay. And then you need to wait until the sample fracture. After the sample fracture, you record the cycle here. So this is your result. Then repeat the same procedure for another 4 samples, but with different loading value. So that's all for fatigue. Have a nice day.
Here are the safety precautions of fatigue testing machine. The signal words danger, warning, or caution indicate the probability and potential severity of injury. An additional symbol indicates the nature of a hazard or a required action. Here are the signal word and its explanations. For the signal word danger, it indicates a situation which, if not avoided, will result in death or serious injury. For the signal word warning, it indicates a situation which, if not avoided, may result in death or serious injury. For the signal word caution, it indicates a situation which, if not avoided, may result in minor or moderately serious injury. For the signal word notice, it indicates a situation which may result in damage to equipment or provides instructions on the operation of the equipment. Here are the six symbols and in its explanation. For the first symbol, electrical voltage. For the second symbol, the hazard or the general. For the third symbol, the hot surfaces. The fourth symbol it means the rotating parts. And the fifth symbol it indicates wear gloves. And for the sixth symbol it means notice. Here is the safety instructions for the electrical voltage and the signal word danger. When the switch cabinet is open, electrical connections are exposed. Risk of electrical short. Before opening the switch cabinet, disconnect the plug from the power supply. All work must be performed by trained electricians only. Protect the switch cabinet from humidity. Here are the preventive maintenance of the equipment of fatigue testing machine. Ambient conditions for operating storage locations are free from dirt and humidity and level and fixed surfaces.
Torsion testing machine. By definition, torsion testing allows a determination of shear properties in a material. Torsion testing twists a specimen to a specified degree with a specified force or until the material fractures. Usage. The purpose of a torsion test is to determine the sample behavior when twisted, or under torsional forces as a result of applied moments that cause shear stress about the axis. Measurable values include the modulus of elasticity in shear, yield shear strength, torsional fatigue life, ductility, ultimate shear strength, and modulus of rupture in shear. These values are dissimilar to those measured by an axial tensile test and are important in manufacturing as they may be used to simulate the service conditions, check the product quality and design, and ensure correct manufacture. Torsional testing machines are used to simulate real-life service conditions and to check product quality for products, such as drill tool bit tips and medical devices, screws and other fasteners, wire, and much more.
There are 15 parts or components of a torsion testing machine that are shown in the image. Number 1 is the hand wheel. Number 2, gearbox. Number 3 is the Jacob's chock. Number 4 is the housing or torqueometer. Number 5 is the torsiometer support. Number 6 is the base. Number 7 is the torsiometer. Number 8 is the digital meter. Number 9, the detachable feet. Number 10 is cable. 11, input shop. Number 12 is the test specimen. Number 13 is the torqueometer. 14, screw. And number 15 is the deflector arm.
How to use the equipment. Select the driving dogs to suit the size of the specimen and clamp it in the machine by adjusting the length of the specimen by means of a sliding spindle. Measure the diameter at about 3 places and take the average value. Choose the appropriate range by capacity change lever. Set the maximum load pointer to 0. Set the protector to 0 for convenience and clamp it by means of knurled screw. Carry out straining by rotating the handwheel in either direction. Load the machine in suitable increments. Then load out to failure as to cause equal increments of strain reading. Plot a torque twist graph. Read off coordinates of a convenient point from the straight line portion of the torque twist graph and calculate the value of G by using relation.
Here is a video demonstrating the torsion testing machine.
In this video, we will be demonstrating the torsion testing machine, the SM1001, for performing torsion tests on different materials and demonstrating the Bauschinger effect. This is part of the materials testing and properties range of engineering teaching equipment from Tech Equipment. The compact nature of this means it's both suited to classroom demonstrations and for use by small groups of students. Engineers need to know how different materials behave when stressed and how to use the correct materials and material sizes for load-bearing structures and parts in their designs. The machine can be used to determine modulus of rigidity and yield strength and the upper and lower yield stresses for normalised steel specimens, as you can see here. You can use this to compare different elastic and plastic properties of materials and carry out reverse torsion tests to demonstrate the Bauschenger effect that I've already mentioned and effects on residual body along with textural stresses on torsional strength. Let's take a look around the torsion testing machine. As you can see, it's a benchtop apparatus with three main parts, the main unit and two separate electronic displays. The main unit consists of a rigid frame with precision engineered alloy box section supported at each end by adjustable feet. This itself carries a strain head at this one end and a torque reaction measurement system on the other side here. You fit the specimens into hexagonal sockets between the output of the strain head and the input of the torque measurement head contained within the torque reaction and measurement system over here. You then turn the hand wheel of the strain head, which consists of a 60-to-1 reduction gearbox mounted on a platform. When turning the hand wheel, you're applying torsional stress at one end of the specimen. This end of the specimen moves, i.e. twists, through an angle, and at the other end, the torque head measures the torque. A transducer measures the number of turns in the strain head, while a moment arm, an industrial force sensor, measures the torque value. A keyway allows the output shaft of the strain head to slide freely along its length that allows for any change in length of the specimen during the test and for easy insertion of specimens. An accurate encoder measures the strain, i.e. the angular movement at the strain head, which has a digital display and can connect to the versatile data acquisition system that we can see right here. The torque reaction and measurement system includes a torsion shaft supported by bearings. The shaft reacts on a strain gauge load cell. For safety, a clear guard protects the user when they perform destructive tests on standard size specimens. Looking at the electronics displays now, the digital angle meter calculates and shows the angle of the twist from the strain head end of the specimen. This automatically converts the amount of turns of the strain head output shaft into an angle in degrees. The digital load meter here calculates and shows the torque of the torque measurement head, automatically multiplying the known torque arm length by the force from a load cell force sensor. The peak hold button allows you to store the maximum reading of torque that is measured during the experiment. For increased strain measurement accuracy, we offer the optional torsiometer, the SM1001A. This is particularly useful for helping to find the modulus of rigidity, i.e. the shear modulus. The torsiometer has a digital display of angular movement calibrated to the strain angle in radians and can be connected to the versatile data acquisition system VDAS. Which brings me nicely on to explain a bit more about VDAS. Used with this machine, you can carry out quick and reliable tests as it gives you accurate real-time data capture on the screen, monitoring and display, calculation and charting of all the important readings on the computer. It also has export capability. The torsion testing machine is a useful companion to TechQuipment's universal testing machine, the SM1000. For more information on the torsion testing machine and the universal testing machine, click on the links in the description box below. Finally, don't forget to like and subscribe to the TechQuipment YouTube channel, and thank you for watching.
Safety precautions while using or near the torsion testing machine. First, always wear eye protection when using or working near to the apparatus to avoid eye injury. Next, before you remove a specimen, reduce the torque or stress back to zero. If you do not use the equipment as described in these instructions, its protective parts may not work correctly. And last, when testing to destruction, always fit the guard.
Preventive maintenance. During the test, check whether the indicator light is correct. Avoid heavy blows during use and handling so as not to affect the measurement accuracy of the equipment. The tightness of the chain of the material torsion testing machine is best to be checked every 6 months. The knots of the equipment should be tightened regularly to avoid loosening. Moreover, the components of the equipment should not be moved randomly. Some electronic parts and circuit boards are very sensitive to static electricity. It is inevitable that there will be some static electricity on the human body which may be damaged. It is best not to place the material torsion testing machine in too humid environment and keep air circulating. The operator should read the manual well to avoid damage to the equipment due to improper operation. Non-professionals should not easily operate and debug the equipment. Once the machine is abnormal, stop the operation and get in touch with the technical staff in time. And that brings us to the end of our presentation. Thank you so much for your interest and attention. This is Crew 4, now signing off.